Okay, guys. So you should have had a chance last week to finish up day 9. This was our homework. It was homework from Friday, and I wanted to make sure my virtual learners had a chance to double check these 7 problems. And I'll go ahead and tell you, this is great test practice. Phenomenal test practice. So when I unfreeze the video, again, I want to make sure you have paused and worked this page here. If you haven't, then let's pause the video. Let's make sure we get these, I think 1, 2, 3, 4, 5 problems finished. And when you're ready, you can unpause the video, and the answers will go through one at a time. Okay. So number 3, what is the probability of rolling a 3 or a number less than 5 on a number cube? There's that word or. We're talking mutually exclusive. And so we can say, okay, the probability of getting a 3 is 1 out of 6. The probability of getting a number less than 5 on a number cube, that's a die, by the way, is 4 out of 6 because we could get 1, 2, 3, or 4. Wait a minute, we've got an overlap here. 3 shows up in both these sample spaces. So then we have to subtract out that overlap because right now we're counting 3 twice. So we say, okay, the probability of getting 3 is 1/6, plus the probability of getting a number less than 5 is 4/6. Subtract the 1/6, and it turns out that really the probability of getting less than 5 already covers this. You can subtract out that 1/6, and so you have a 2/3 chance of getting either 3 or a number less than 5. Next one, I really like number 4. Check it out. I'll show you guys both these because I don't have them fully answered here. So number 4 is a mutually exclusive problem. Event A has a probability of 0.25, so a 25% chance, and event B has a probability of 40%. What's the chances of either one of those happening? So we're fine with one or the other. And if that word or comes in and we're talking mutually exclusive, we're going to add those probabilities. So you add those together, and you get 0.65, or a 65% chance. Now with independent, that means what's the probability that they both happen at the same time? So A and B. Well, here's the problem. If both these things are going to happen, that's going to hurt our probabilities because the chances of one thing happening is it's one probability, but when both things need to happen, that's going to hurt our probability here. So we multiply, and if you do 0.25 times 0.4, you end up with 0.1 or 10%. So there's only a 10% chance that both event A and event B could both happen compared to A or B where we had a 65% chance. Stick with me, guys. Only 3 left. So number 5. We win 4 out of every 10 races, unless it's you, in which case, you win 10 out of 10 races. Your friend wins 5 out of every 9 swimming competitions she enters. Okay. Well, I'm not a very fast swimmer, so that definitely wouldn't be me, and I'm not a she. What's the probability of you both winning? Ooh, both. If we see that word both, I want us thinking independent. We're thinking independent, and if we're thinking independent, we're thinking multiply. So here's our probabilities. So we need to do 4/9 times, 4/10 times 5/9. And whenever we multiply those together, you end up with 20 over 90, which reduces down to, I'll put it down here, that's 2/9. So not very good odds. And which one of these do you think hurts our odds more? Us winning our race or our friend winning their swimming competition? Yeah, it's definitely us. We're kind of holding it back there. We only have a 40% win percentage, whereas they have almost a 60% win percentage. So we're the ones who kind of ultimately hold them back. Now, if you're not a gambler or you don't have an addiction, then you may not understand how the distribution of cards is in a standard deck. So in a deck of cards, there is 4 of every card. So in the case of drawing a king, there are 4 kings. And in the case of how many cards there are in a deck, we're talking 52 total cards. Now, diamonds. There are 4 suits in a standard deck. So you've got this split 4 ways. You've got hearts, diamonds, spades, and clubs. And each of these has the same number of cards in each. So what's 52 divided by 4? Oh, it's 13. So there are 13 of each kind of card. So there are 13 diamonds. And what's the wording you guys see here? The probability of drawing a king or a diamond. Okay, so we're talking mutually exclusive. So we are going to add these probabilities. So what's the probability of getting a king or a diamond? So we go probability of king or diamond. We got 4 out of 52 plus 13 out of 52. Oh, shoot. Here's the thing, though. Do you think there could be a king of diamonds? Yes, there is. So right now we are counting. Let me switch up colors here. We are counting the king of diamonds twice. Can't do it. We're counting the king of diamonds twice right now. Once there and once there. So we need to subtract out that king of diamonds. So we're only counting it one time. So you add those together. You get 16 out of 52, which reduces down to 4 out of 13. 4 out of 13. So not great odds, but actually not as bad as you would think. And the reason that really saves that is because of the diamonds, right? If a fourth of the deck are diamonds, that's going to help your chances quite a bit. Last thing, guys. What's the probability of rolling a dice and not rolling a 2 or a 3? Now throw it back to chapter 1. If we're trying to find the probability of something not happening, we call that a complement. Complements. So how many options aren't 2 or 3 is the real question. Well, if you roll a die, you could get a 1, you could get a 4, a 5, or a 6. So the probability of not getting a 2 or 3, that's 4 out of 6. That's pretty good odds. And so you're looking at, you got a 2/3 chance of not rolling a 2 or a 3. So thank you guys, and hopefully that answered some of your questions. And again, this is going to be a lot of our tests, so make sure we're feeling good about probability.